Good morning once again. How are you all? So today we are back again with a new video on the topic which we were discussing yesterday, that is factors affecting resistance. Yesterday we discussed a few of the factors, that is length of the wire and area of cross section, and we derived this expression R equals to rho L upon A, which is very important for your numerical point of view. What kind of numericals will be there, that I will be discussing today with you all. So, third factor was left, that was temperature, and temperature is a very important factor which affects resistance of a material. Now, important thing is that resistance depend differently on different kind of material, right? Different kind of material, you know that material are different kind, like we have two kinds of material. Some are called conductors and another are called insulators. Okay, some are called conductors and another are called insulators. Now you know conductors are the material which has the ability to conduct electricity, and insulators are the material which do not have the ability to conduct the electricity. Now, how resistance depend on temperature for conductors and insulators? Now, for conductors, resistance is directly proportional to temperature. What does this mean? This means that if temperature will increase, if you will increase the temperature of the conductor, the energy will be gained by the electrons. They will start moving at a fast rate, because of which the collision will increase and the electrons will start diffusing, right? So the number of electrons will start reducing. Okay, so when the number of electrons will start reducing, so the resistance will start increasing. So for the case of conductors, when temperature increases, the resistance of the material will also increase and there will be less amount of current flow through the conductors. For the case of insulators, resistance is inversely proportional to temperature. You know, insulators are the material which do not conduct the electricity. So when you increase the temperature of insulators, so what will happen? There may be a possibility that few of the electrons may acquire such energy that they start conducting, right? So in that case, the resistance will reduce. So resistance is inversely proportional to temperature for the case of insulators, and it is directly proportional to the conductors, right? So this is the third factor which we left yesterday, that factors affecting resistance. One is length of the wire, that is R is directly proportional. Then second was area of cross section, that is inversely proportional, and temperature was the third case, and in this case the conductors behaves directly proportional and insulator behaves as inversely proportional to the temperature. Okay, so now we will discuss about the numericals based on R equals to rho L upon A. As I told you earlier that the expression R equals to rho L upon A is very important for you. It will come in 3 marks. It will have parts also. It may be the question like define resistivity, and a numerical will be added on to it. So this kind of question generally asked from this expression. So I have written a question over here that the resistance of an electric wire is 10 ohm. Resistance is given to you if the thickness of the wire. Now the thickness of the wire, you know that wire is we generally consider as in the form of cylinder, right? And this is called the thickness of the wire, this. So what is this? This is a circular shape, so it will be a diameter. So thickness symbolized to diameter. Remember this, thickness symbolized to diameter of the wire, right? So it is given to you 0.001 meter. meter. Okay, so this you can write. So what will be the radius? The radius will be equals to 0.0005 meter. Okay, so this is given to you thickness, and the length is 1 meter is given to you. So length of this wire is given to you 1 meter, and its resistance is 10 ohm. Calculate its resistivity. So first of all, you have to write the solution with given what all is given to you when you will be finding out the solution of this. So first you will write given is R equals to 10 ohm, right? Length equals to 1 meter, and A you required area of cross section. So A equals to pi R square, because what it was, it is a circular. The area of cross section is in the shape of circle. So for the circle, you have to find out the area. What will be the area? Area is pi r square. So it will be 3.14 into 0.0005 whole square. So you will calculate it. You can convert it in the form of exponent also, right? So it will be 3.14 into 5 into 10 to the power minus 4 to the power 2, right? So this exponent will open up. So this will be your 3.14 into 5. It will be 25 into 10 to the power minus 8. So you will multiply this. So when you will multiply this, you will get you can multiply this, and A will come as, it will be 3.14 multiplied by 25. So it will be 0, 10 carry, 135. It will be 3 carry, and 75 is 78. 78.50 into 10 to the power 0.50 into 10 to the power minus 8 meter square. Clear? So now you will put this formula R equals to rho L upon A. Now what you will do? You have to find out rho. So you will just, this implies rho equals to R A upon L. Now you will put the values. All values you know. 10 ohm into 78.50 into 10 to the power minus 8 upon 1. So you will calculate it. What will be the resistivity? So 10 to the power 1 it is, and minus 8 will be minus 7. So it will be 78.50 into 10 to the power minus 7 ohm meter. So this will be the resistivity of the given wire. Okay.